Hello everybody, this is Ivy Produced, back with another hackathon submission. This time it's for a GitHub Copilot CLI challenge. I use GitHub Copilot CLI to build a tool that uses GitHub Copilot CLI. Meta? Yes. Game changing? I think so. This is OSCALFLow, an AI-powered federal compliance automation tool. Federal systems need up to 400 plus NIST controls. Manual documentation takes months, but what if AI could validate implementations and suggest fixes? That's OSCALFLow, powered by Copilot CLI. Here's FedChat, a LibreChat fork that I hardened with the intention of deploying to federal environments. This is what we're going to scan for compliance. Here is the command. We did use the GitHub CLI and we used the Copilot CLI to add a Copilot CLI implementation into the GitHub CLI application. That's a lot, I know, but you'll see. This is our command. gh-oscal scan test case fedchat, and the output is going to go into a scanresults.json file. So let's run that command and see what happens. So what this command did is it scans our repo and it looks for any files that could potentially address security controls. It's pretty cool, I think, at least. And so we can take this a step further by modifying our command just a little bit. So now what we're going to do is we're going to go ahead and copy this command back in. With this command, we're going to scan the test case fedchat, and then it's gonna find all of these controls and these documents. And so what the AI validate is going to do is going to take those files, scan it with AI, take the NIST requirements, and evaluate the evidence against the NIST requirements, and then it will provide us with a validation not a validation recommendation, but a validation output. Basically, is it validated or not? And so we're only going to do 5 for the purpose of this demo because it can take a while for the AI to respond. So we don't want to sit here and watch this all day. So we're going to run that command, and while that is running, so the AI reads the actual code against the NIST 853 requirements from the official OSCAL catalog. There's no guessing, no hallucinations, real validation. This is the difference between we think we're compliant and AI verified that we're compliant. And it didn't just verify it based off of its training data, it verified it based off of the actual NIST OSCAL catalog. So the results come back, and it tells us that we've got 1 out of 4 controls that have been verified to be accurate. So although we found all of these controls that are potential implementations, they're not all necessarily there. We got to validate them. And so we validated only 1 of 3. So now we don't know how we are supposed to get those controls to become verified. Well, we created a way to do that as well. So we have another command that we will copy in. It's going to suggest AC2. We didn't scan AC2, so we'll do instead of AC2, AU2. It's going to go through, it's going to look at the AU2 control from OSCAL, and then look at what we have implemented, see where we fail at, and then it will suggest what we need to implement by scanning our code base again. So let's check that out. And we can see how this goes in real time. It knows that it's a Python application with Docker. It's going to scan everything, and then it's going to go ahead and give us recommendations on how to fix our code with respect to AU2. Copilot CLI is analyzing the actual code base, it's reading the files, it's understanding the architecture, and it's detecting the frameworks. And you can see that because earlier it stated that we were using Python and Docker. So it knows that we're using Python and that we're also using Docker because they're Docker files. So it's looked, okay, your code base already has a solid foundation, the struct log, the audit middleware, basic audit logging configuration, and audit configuration. However, there were some gaps identified. There's limited security relevant event logging beyond HTTP requests. There's no dedicated event logger. It's missing specific event types, and there's incomplete user context extraction in the audit logs. So it'll go through, it'll create an implementation plan, and it's not actually creating any files. This is just telling you what you should do. And it will save everything to a file to be referenced later. The saved file will include implementation steps with full code, database migrations, API endpoints, background jobs, testing, everything needed for AU2 compliance. Oh, and one more thing. I did set this by default to use one of the included models that don't use a premium request in GitHub Copilot because I did not want anyone to burn through all of their premium requests using this tool. Now you can set it to use a premium model, but I recommend you keep it with the included models because you can use up a lot of premium requests with this. However, your premium requests, your choice. You can choose to do it however you want. And that's it. It's done. You've got the AU plan right here, and this is our implementation plan. You could then feed that back into Copilot CLI and have it implement these things for you. Thanks for watching this demo. Hopefully it's a winner. And that is OSCALFlow. Hopefully this can help you with your compliance work and save you a lot of time. This is open source. It's an MIT license, so feel free to contribute to the project. Feel free to take it and do some things of your own with it. And that's all for me for now.